Good afternoon. I am Rubana Khan, Assistant Professor in Department of Computer Technology, Priyadarshini College of Engineering, Nagpur. Today, I am going to introduce you the subject Computer Architecture and Organization, which is included in third semester scheme of Computer Technology branch. So today, I am going to cover introduction of the subject, then why we require to study the subject Computer Architecture and Organization, objectives of the subject, various applications where we can use the knowledge which we gain from the subject, and the content of the syllabus that is included in the CT branch. So, as we know, our world becomes the computer world. Everywhere we use the computer. In daily life, either we are using any home appliance like microwave oven, digital camera, washing machine, anything, smart appliances, that all are smart appliances where computer is inbuilt. Our laptops, tablets, our smartphones, everywhere we are having the computer. So here we need to understand how a computer actually works, what is there inside the computer, what are the components which are present in the computer, how they are connected, how they are organized. So that is what about computer architecture and organization. So see how our computer looks in real world. We see the computer like there is one output device, there will be various keyboard device, there will be one cabinet. This is just the cabinet where we have the processing elements that work actually. These all are the hardware which are of no use if we don't know how these processing elements work. So this is the basic computer architecture, and here we'll get the block diagram of this computer where there will be the motherboard where you will have all the ports through which these input output devices are connected. There will be the processor. In processor there will be your control unit, your arithmetic and logical unit. There will be various memory storage devices. So see, we can say our computer is a very complex structure, or your computers have a very complex structure. See, this is the motherboard. All that we have seen, like there will be input devices, output devices, there will be processor, that all included within this small chip. So computer architecture and organization is the study of internal working of all the components which are present in these motherboard, and implementation of those individual components together. So these two terms, that is architecture and organization. Architecture simply means you can define the architecture as the art or science of designing any object. So in real world, everything is like an object, and every object has some architecture. So if you consider about the building has the architecture. Okay, it has some objects, their physical characteristics will be there. So like that only there will be computer. In computer there will be small functional units, and these functional units, how they are specified, how they are described, and how many number of those elements are required, that is called as what? Architecture. Then organization, implementation of that architecture is called as the organization of the system. So why we study this computer architecture and organization? Because we use the computer every day. As a user, we are using the computer. As a computer science student, you should know this subject, because if you are going to perform, if you are going to make any software, you should know how your hardware is designed, so that implementation of your software should be troubleshoot if any error comes. So knowing what's inside and how it works will help you to design, to develop and implement the applications better, faster, cheaper, more efficient and easier to use, because you will be able to make informed decisions instead of guesstimating and assuming. So that is what actually why we study this computer architecture and organization, and use these basic fundamental concepts in your remaining subjects, or in your remaining career. So this course is about what computers consist of, how computer works, how they are organized internally, what are the design trade-offs, and how design affects programming and applications. So basic objectives: to know what are the various functional units which are present in the computer, what is the working of those components, how they are designed, then how they all are connected with each other to form a system. Then, so in real world application, obviously, if you are going to make some software, whether application software or system software, so if you are performing the performance analysis of the software, you should know the design of the hardware, on which particular hardware this software is going to be implemented. For parallel software and its execution, you should know the design and architecture, how your components are designed. Obviously, in embedded and mobile computing, you should know what type of component is, what type of hardware, what type of CPU is used, what type of operating system is used in your system. High performance game programming. Obviously, high performance, if you are going for programming the high performance games, then you should know on which particular hardware these games are going to be implemented. So these all are the various applications in real world of the subject. So overall content of your this subject based on this diagram. Here you should know the functional unit of the computer system. What are the various functional units? You should know what are the various components, that is input devices, output devices, then your CPU, what is the working inside the CPU, that will be covered in the subject. Then how many memory devices are there, how these memories are organized so that you can store your data into the memory and CPU can fetch those data and instructions and execute it. Then now we'll go through the syllabus that we have in the CTech branch, that is in unit number 1. First, we are going to see what is the basic structure of the computer system, in which we'll have the functional units, that is input devices, output devices, memory system, and your central processing unit. Then inside the CPU, how your instructions are executed. In your CPU, there are various registers like your memory data register, memory address register, where your data and addresses are stored, from where the data is to be taken and executed inside the CPU. Then all these components are connected via some communication mean, that is called as what? Bus. So we will see the various types of bus structure here, that is data bus, address bus, and control buses. Then obviously, if we are learning about the hardware, this hardware will be of no use if there is no software. So what is the connection between these hardware and software, that will be covered here. Then after that, we'll see how your programs, whatever the programs, whatever the instructions, or whatever the data is stored inside the memory, how they are fetched to the CPU so that CPU get execution. So for that, we will see the various type of instructions here. Then assembly language programming, various types of addressing mode, that is the way by which the data from the memory addresses are fetched, that is called as what? Addressing mode here. So in next unit, we'll cover see, all the units are interconnected. So if we have seen the basic functional units in the unit number 1, and we are starting with the CPU. So in CPU, what are the basic model of the CPU? What can be the components of any processor? Like there will be instruction register, there will be various data register from where the data is to be taken for the execution, right? So how these instruction, what are the various types of instruction, that is single byte, 2 byte, 3 byte, 4 byte. There will be various types of instructions that are stored into the memory and they are fetched inside the CPU so that execution time will become very small. in very quick instant your instructions are going to be executed because they are already fetched inside the processor. So that's why they have the various types of registers, various general purpose register, instruction register. There will be program counter, that is where the address is present from where the next executable instruction is should be fetched. So here in unit number 2, we are going to cover that only, processing unit. Processing unit में how these instructions are executed. How one complete instruction, if suppose I am saying add R1 comma R2, you have to take the data from R1 register, that is general purpose register, add this content with the general purpose register named as R2 content, and add the result into R1. So in one instruction, there are various micro operations. Okay, at this particular cycle, at this particular clock time, what micro operation is to be performed. So for example, this add R1 comma R2. So first what is needed, you have to fetch the instruction from the memory. Once the instruction is fetched, it will be loaded into the register IR. Then decoding of that instruction is done. Then after decoding, your processor will come to know okay, where is first operand is present, where is second operand is present, and what type of operation is to be done. Then your first operand is fetched, then your second operand is fetched, and the particular arithmetic or logical operation is performed. So that is what here in unit number 2 we'll do. Next, in unit number 3, obviously in CPU we have the arithmetic logical unit and the control unit. One unit ALU which performs the operation, and one unit that is control unit which gives the signal what type of operation you have to do. So that control unit is already covered in unit number 2. So in unit number 3 we will see what type of operations, arithmetic operations are performed inside the ALU. So basically two types of number system, that is fixed point number and floating point numbers. So we have to cover fixed point number operations in detail here in unit number 3. That is, first we will see what type of number representations are there, then how you will perform the addition of two fixed point numbers. So for addition and for subtraction, we have adder and subtractor already. These ICs are available. But in basic model, like in 8085 microprocessor, we don't have the circuitry available for multiplication and division. So that's why we require some algorithm which will perform the multiplication and division. So that algorithm we'll see here. For multiplication, we have Booth's algorithm, then fast multiplication, bit pair recording method, and for sign division, we have restoring method and non-restoring method. So in the same way, floating point number, what is floating point number, and what are the various representation, that is IEEE 754 single precision and double precision representation of floating point number, and various operations, that is addition, subtraction, multiplication and division, how they are performed on the floating point number, that will be covered here. Then next comes, so till now we have seen what in our operation, in your basic functional unit, we have seen input device, output device, your central processing unit, inside that ALU and control unit. So we have covered ALU and control unit in unit number 2 and unit number 3. So unit number 4 composed of your memory system, where your data actually present. So as there are two types of memory, we all know, primary memory, secondary memory. Secondary memory where we actually store our data permanently, but CPU is connected with the bus with our main memory, that is RAM, where the actually data is loaded while execution. So for that we can say, for execution your data should be present into RAM, present into main memory. So loader is there which will load the data from secondary storage to main memory here. So as the data comes into the main memory, you here, as the subject is what about hardware, so you should know what types of cells are used to store the data. So basic here we use, obviously for storage we know flip-flops are the basic component which is used to store our 1 bit of data. So here in RAM there will be different types of RAMs, that is your static RAM, dynamic RAM, then there will be ROM. So here we can use the different technologies to store the data. So here we'll see the various memory hierarchy, what type of memories can be there. That is simply in CPU, there will be various general purpose registers where you can store the data for execution. But as these registers are very less in number, so that's why we are having some other memories, that is cache memory, which is connected between your RAM and your CPU. So that once you are fetching the data from the RAM, that one copy of that will also be stored into the cache memory, so that next time whenever you are giving the address, your CPU will give the address to fetch the particular data from the RAM, that will be surged into the cache memory, and if the data is available already there in cache memory, that will be given to the CPU directly. And if it is not, then it will go and search into the main memory. If it's present there, that will come to the CPU, as well as one copy will be stored into the cache memory. If again in RAM data is not available, obviously your whole data and program is present into the secondary storage. So it's the task of your virtual memory management, that is operating system, to bring the data which is required at this particular time whose address is generated, bring it into main memory from the secondary storage by the concept of paging, segmentation, hybrid method, and then that data will be loaded into RAM. Then again from RAM it will be given to the CPU registers, as well as one copy will be stored into the cache memory. That is how your memory management operating system and what type of hardware is there, how they work together. So done with control unit, your LU, then memory, then last is what here? Obviously input output devices, various types of IO devices which are available, that we'll see here. Then how these IO devices work with the CPU, if they want to send the data to the CPU, how they interrupt the system, because every time your CPU is the master, any other device cannot directly go inside the system and use the system buses. They have to take the permission from the CPU. Okay, whether can I send my data, can I use your address bus, can I use your data bus, can I use your control bus? So that is what interrupt. So every time whenever any IO device want to access the CPU, access the resources, it has to interrupt the system. So here we will see the various types of interrupt mechanism. And then if any device want to directly communicate with the memory, then direct memory access will be there. Then synchronous asynchronous data transfer we'll see. Then we'll see the higher version of processor, that is RISC and CISC processor, array processor, loosely coupled, tightly coupled system, vector processing. These all are the parallel processing advanced processors that will be covered in unit number 5. So after completing all these, there will be various outcomes from the each unit. So for example, in unit number 1, we have seen the basic functional units, operational concept of the computer system, and we will apply the assembly language programming for that. So that is the outcome of unit number 1. Then from outcome of unit number 2 is various instruction formats. We will illustrate the various instruction format and interpret the execution of complete instruction in the processing unit, control unit, and sequencing. Then unit number 3, we will analyze and apply the logic circuit for implementing arithmetic operations, that is addition, multiplication, and division. Then we will compare and analyze various memory system, including semiconductor, ROM, RAM, cache, and virtual memory. And in unit number 5, your outcome will be your students will be able to explain the computer peripherals, classify advanced processor and processor families. So by this subject, we'll get the basic knowledge, that is fundamental concepts, how your computer is architectured and how it is implemented by the organization. So here various textbooks which are available, that is Computer Organization by Hamacher and Zaki, 5th edition, that you can use. You can go through with the Computer Architecture and Organization, that is Hayes book, 3rd edition, and Computer Organization, Design and Architecture by Sajjan G. Shiva, 4th edition, Computer System and Architecture by Mano, then Computer Organization and Architecture by Williamston. So thank you.